Hi there. Let's take a tour to one of the World Heritage Sites. This is Qutub Minar. The height of Qutub Minar is 72.5 meters, making it the tallest minaret in the world built of bricks. Assume that you are here and watching the Minar. If we consider the lines from your eyes to the ends of the Qutub Minar, there is an angle formed between those lines. We say that the Qutub Minar subtends an angle at your eye. The concept of subtending an angle is something we often see in circles. Let's say we have a circle with 3 points on it, say A, B and C. On joining these points, we see that the chord AB subtends angle ACB at C. Not just that, the arc AB subtends an angle of ACB at C as well. And when we join A and B to the center of the circle, that is O, then we can say that the chord AB and the arc AB subtend the angle AOB at the center. Now let's focus on the arc. It subtends two angles, angle AOB at the center and angle ACB at the boundary. Is there a relation between these angles? Yes, there is. Angle AOB is twice the measure of angle ACB. This brings us to an important theorem. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. And this statement holds good whether the arc in question is the minor or the major arc. Let's see how we can prove this statement mathematically. We have a circle centered at O and we have the arc AB subtending angle AOB at the center and angle ACB at the remaining part of the circle. We need to prove that angle AOB is twice angle ACB. We need to join CO and extend it to D like this so that we can prove the result. When we consider triangle AOC, OA and OC are equal as they are the radii. So, angle OAC is equal to angle OCA because they are angles opposite to equal sides. Now, the exterior angle AOD is equal to the sum of interior opposite angles OAC and OCA. Since these two angles are equal, we can write it as 2 times angle OCA. Let's mark this as equation 1. Similarly, in triangle BOC, angle BOD is equal to 2 times angle OCB. Let's mark this as equation 2. On adding the equations 1 and 2, we have this equation. Angles AOD and BOD on the left hand side add to give angle AOB. We can take 2 as the common factor on the right hand side and simplify that expression to 2 times angle ACB. There we go. We have proved our result. But is that the only way? Let's look at the figure again. If we move point C like this, such that AOC is a straight line, it becomes much easier. In triangle OCB, OB and OC are equal. So angles OBC and OCB are equal. Let's call them X. Now central angle AOB is the sum of angles OBC and OCB, exterior angle property, which means that angle AOB is 2 times X. Which means angle AOB is 2 times angle OCB, which is 2 times angle ACB. So we observe that in both the cases, the angle subtended by an arc at the center of a circle is double the angle it subtends on any part of the circle. Now you go back to class and deduce some important relations using this theorem. I'll see you next time.